Because really the history of human society has been a battle of ideas, right? We know that human society, and I think Paul went through this wonderfully, human society, though we have many differences as humans, we live in a material world, we live in space, and we have a duration, right? We're born, we die, and every one of us has differences physically from the other. Every culture has differences from the other, different cultural experiences and reflexes. But regardless of all of this difference, we do coexist on Earth, and we do have certain qualities that we share in common. Now, the thing that pisses off imperialists is the fact that there has been, like Paul was going through, a quality within that's manifested itself in various cultures over the millennia of individuals stepping outside of the limited matrices of their time. Right? People who have chosen not to be bound by their cultural traditions, who have chosen not to follow irrational habits that have been expected upon them by their forebears, and have chosen instead to be creative and make discoveries of qualities that govern the universe. Right? When we talk about unifying the world amongst all these different various countries come together, we don't mean we want them all to have a unification of McDonald's, or three-car garages. We're not talking about these things. What we're saying, though, is that what we have with China and with Russia, both with a common orientation towards developing industrial automated processes to mine helium-3 and other rare earths on the moon, is an expression of this human quality that we can actually make leaps outside of what is already known and discover those laws that the universe has shaped. Well, let's shape the universe and that shape us and our development, and then act upon those discoveries in ways that have the effect of making our society a better place for our children and grandchildren, everyone from after. And when we don't do that, and when empires crush that Promethean spark that says, no, fuck Zeus, right? Fire exists for everybody. It's not the possession of a mighty few who have the will to power. That Promethean spark, when that's crushed, we get a dark age. And there's a science to dark ages just as much as there's a science to Renaissance. And so what Paul went through, and what's very important for everyone to conceptualize here, is that though we are seeing the emergence of a completely new system, what's coming out of the Brits and their affiliations, it's many cynics who just aren't that well informed about history and what have you, will otherwise say, oh, that's just another empire taking control, vying for control of the system. Right? We have this empire that's collapsing, yeah, sure, but now you have this new red dragon and this new alliance that are just there to take over the system now. And in fact, what they're missing is that it's not a battle of empires, it's a battle of conceptions. Whether you unify your system around like Paul went through this legalist system where everybody just gets into a fixed harmony, where everybody just knows their role and behaves according to a master class. That's one way to do it. Every class does it that way. Everyone knows your role. And like waves. And that system is an empire system, and that's one way to create a unification of the many. The other way is to actually say, no, we're going to unleash creative optimism. We're going to make our society geniuses. We're going to or at least create an environment where genius can flourish, like pretty culture of engineering scientists, by having visions for the future to do the impossible. And people like John F. Kennedy did that. Right? Many people here are much older than me, and I think that we have some memory of what went on when John F. Kennedy and people who worked with him, like Martin Luther King and Robert F. Kennedy, were inspiring people to think not about your limits, not about yourself as a consumer, but rather think about yourself as a creator first. Of course, we all consume. We have to, or else we can struggle with that. But is that where you're going to locate your identity? Right? As the consuming species? Or is your primary motive and the species character of primary creative, productive species? Right? And when you look at the divergence right now between where you have an advance towards adopting a nuclear strategy with both advanced second, third generation moving towards fusion economies, you have primarily the Brits that have 65%, and all of the other countries, only 35% that are not Brits. In fact, what we have is coming out of Germany is the contraction and destruction of the nuclear potential that was built up. So Germany is now planning by 2020 to have a 0% nuclear basket. Spain is going down to a similar level soon, if the current system's attention is maintained. And against this, you have those, especially coming out of India and China, who are saying no. And this came out of COVID, right? If you guys remember, in 2009, the break fully became defined when all of these countries, especially in Asia, were expected to come together and sign a suicide pact. Basically say that we will sign binding treaties to get rid of our sovereignty, have new global green arrangements to enforce programs of cap and trade, carbon cutting emissions, things that will, as an effect, force these countries into massive depopulation and chaos. Because when you have over 1 billion people in a society, windmills and biomass is not going to cut it to sustain that population. And what China and India especially did is they basically locked themselves in the room and said, we're not going to sign a suicide pact, thank you. And they made a complete break in energy and geopolitical policy. What the empire hates when you have people unifying around a policy like this is that, well, geopoliticians, they thrive on our differences, right? On keeping everybody in a world of scarcity, looking at the other as some foreign thing that you can't really relate to, right? So they cultivate a better atmosphere for better uranium and also civil war and conflict that we see coming out of Palestine and every other conflict in the world. This is geopolitical art, and evil art, if you want to call it that goes back to before Babylon. So this is an old precedent. Now what we have are these countries that are going with a program that we left off, and go to the next slide, that we actually had as a governing principle up until the late 60s, early 70s, when you can see, this is the paradox right there. At every state where a society chooses to exist at, your resource basket is finite, naturally, right? Of course. And every moment that goes on, if you do not make creative discoveries to go beyond what currently exists, you're accelerating a collapse point, just like any other animal species that is in its environment, it collapses. Because that animal species, that rabbit population, isn't going to find a better form of agriculture to produce better products. So human beings have that same obstacle. And from the 1780s, what you're looking at here is the U.S., but it's very similar in Canada. What you've got is 5 kilowatt per capita was what the whole system offered to every individual. Like every individual who has maybe, I think it's 2,000 kilowatts of energy within every human being. No, sorry, 200, sorry. Every human being, if you look at the general work of heat that we emit as a biomass, as a species that exists, it's like, we even have fire, it would be about 200 kilowatts per individual of work that is generally done on average. By the time 1780, the American Revolution rolled around, that had increased. It says, it was actually 2,000 kilowatts, based on the steam power that had just been introduced, certain other forms of fire, and a little bit of coal. And that didn't really change that dramatically until coal became more used and adopted, and you had an increase of the per capita power that every individual had available to them in their consumption and production capabilities. That, again, you have a limit. There's only so much coal you're going to get. At a certain point, that's going to collapse. So, at that period, you had a move towards natural gases and oil, which it served its purpose. It was useful when it was. It still is kind of useful, but frankly, rather than continuing on with the policy that John F. Kennedy, that C.E. Howe in Canada, and many others around the world that Charles de Gaulle were moving towards, which was a nuclear-based economy to get rid of, to overcome the limits to existence that these previous states had imposed upon us. Instead of doing that, we only got, basically, only a little bit was cultivated. So rather than moving along this current trajectory, this relative trajectory, where you have these different potential growth patterns, which should have been the case by 2025, of like the John F. Kennedy administration, which I presumed that we would have, these are actually thousands, 20,000 kilowatts per capita by now. A 1983 EIR analysis that presumed it was going to be a bit more, and then a more recent one that had it even higher. Instead of going along the natural trajectory of moving towards higher energy plus densities, higher capacities of production and consumption, and intelligence and morality, rather than moving along that trajectory, the space program was canceled. The assassinations in the 60s went straight ahead.
you had the dismantling of all of the programs of nuclear power development that JFK had put into motion that were then sabotaged. And a similar process occurred in Europe. So we have now reached a point where we have only about 10,000 kilowatts per capita. And on average around the world, instead of going with
Offering these countries in Africa and South America
advanced technologies, as JFK again had, that was his policy, that was what Roosevelt
was planning to do, instead of offering those things,
we went backwards
and we subjected all of these economies into dismantling their nuclear power.
as Argentina was forced to do.
When throughout the 90s, if they were going to receive the IMF loans, they could only get the loans
On the condition that they turned their nuclear reactors into mothballs, that they deactivated them, and they did the same for many other economies. And for those countries like that in
Pakistan under
Bhutto, who wanted in the 70s to go for nuclear, you had assassinations, you had overthrows to keep these economies stuck under a geopolitical model, as Paul went through, of oil and gas manipulation. So that this natural tendency was carved out, and this is where what we see coming out of the BRICS countries
is they're picking up where we left off.
You have an engagement now to recognize that if you don't develop, you're going to collapse.
Right. So today we've got a problem where most people don't really,
when they think of radiation in the West, they're completely emotionally turned off. There's almost like a guttural reaction of three-headed fish, teenage mutant ninja turtles, ooze. It's a very, very
Thanks to
Homer Simpson at the
years.
and
There's this conception that the world would be a better place if there was just
no radiation. That the natural order of things is that there's these objects
that are not radioactive, and then there's this other foreign stuff of radiation that are very
destructive to living things that we don't want to have anything to do with. Fukushima, you name it. And this has been pumped up in the media
from 3 Mile Island to the nuclear.
The idea of a nuclear bomb going off in people's heads when they think of the atom. All this stuff has been pummeled for 3 or 4 generations so repetitively that you got
really an irrational reaction against it without really a deep knowledge of
what is the atom? How did this come into being in the first place? And what is radiation when we talk about it?
So I'm just going to clarify a few of these things in the course of this class and feel for some questions. But the first thing
is to recognize that what you're dealing with is something which is a rejection of sense perception.
Scientifically, the way empires have
Always worked to maintain a culture of dark age has been by keeping the victims of that culture enslaved in an environment
that encourages the belief in sense certainty.
that your mind is slave to your 5 senses. And any abstract thoughts that you have to be rooted in some
empirical, either empirical observation, that's something you can taste, touch,
smell, or
feel, or see,
or some irrational abstraction itself, like
to say that you have to assume that just 2 lines going on parallel directions will never touch if they go on into infinity. You have to just assume that which we'll never know, will never be to infinity, is the case.
even if
it can be proven that space has a curvature, if that's the case, the 2 lines will not actually go on in a real physical world into infinity. But all that to say, the cult of sense perception has been maintained in various forms in various cultures by empire, from China to Europe to India. And for most of human civilization, we've only had access to a very small portion of the electromagnetic spectrum.
right, really only about
1 octave, from 400 to 780 nanometers have been accessible to the human experience. And that's been what we've been limited to and trying to figure out what is this universe that we live in. And so people today, they often take for granted that we now know that there's this big, this very large spectrum that goes outside of our senses, but they don't know how it was discovered. In your time trace, I'm not going to go through every single aspect of how this was discovered. But by actually reliving the experiences of those who did so, who came off the fields of Benjamin Franklin, they're going to realize, and it wasn't really Benjamin Franklin, but the real Prometheus of the world in his period, who not only created a new type of system of government, but also stole fire from the gods in the form of electricity and shared it with both the poor and the nobles alike. It was actually by organizing the nobles in Europe that he was able to get them to assist him in the conspiracy
that is known
as the American Revolution, which is supposed to be replicated in France. That's another story. But this whole process was set in motion largely by Benjamin Franklin's intervention. And people like John Herschel, who discovered that there exists outside the sense perception by looking at the different temperatures of the different colors of light, that there's a gradient of things getting warmer as you go towards red. And even when you leave that red, you discover that though there was no light, there was still, it was getting hotter and hotter. Right? And just as one of his associates discovered that even if we move beyond the blue and purple end of the spectrum, when you take certain types of metals, like silver fluoride, which gets very, very dark when it's put into the sun, all of a sudden you realize that it got darker at a quicker rate as you move toward the purple, and it got darker almost immediately when you moved out of the visible purple. And there wasn't any light hitting it, but it got dark immediately. So the idea then to investigate, well, what is this other domain of action, which is which has been dubbed the ultraviolet, could then be investigated. Things like the luminescent properties of certain minerals, of which there are many, and I don't know if I even have those here. No, I don't even have that yet. I should go down like 3. Sorry. I don't have control of my thing, so put that one more. Put that one more. One more. Okay, go back up. Okay, so there's something besides I can say. Okay. What he discovered is that by looking at different minerals that exist in nature, that when they're hit by ultraviolet light, they all of a sudden start glowing in a luminescent form. The causes of that were something you couldn't even investigate in a previous system. And the freedom to even investigate what's causing that was only made available when you not only discovered that there was this binding principle, that you chose to willfully obey. Right? As a scientist, that's what you are supposed to do. You discover something which you can prove to be true, and then obey it, and your freedom is increased. Because you don't have to. This puts into, this offers something new towards this whole paradox of whether we're a society, if we exist in a universe of law, do we have free will? Well, it doesn't matter what the monarchy believes we should or shouldn't do, or what Wall Street bankers think we should or shouldn't do. But we should ask, what does the universe think we should or shouldn't do? Right? Based upon certain real parameters of value, which is what we're really getting at. And this is what all good scientists think of. How is my freedom to think creatively, make subsequent discoveries that will have effects on bettering the lives of people, going to be impacted by this direction versus that? So ultraviolet light was then developed, and what you had, actually, I'm just going to stop that right there. No, I'm just going to, I'm dropping a bunch of my slideshow right now because of the lack of time. What you had after that was a fellow by the name of William Röntgen. And William Röntgen, who's heard of William Röntgen? Okay. So this is the fellow who discovered.
I don't actually remember.
Oh, okay.
Answer your first question.
X-rays. So what was he doing? Well, he was basically trying to figure out how it was the case that these luminescent properties were being activated by a gas. That when you put a gas in a vacuum, all of the noble gases, when you put a charge into them, a positive and a negative charge, because that's what we're dealing with these old TVs, the cathode ray. You put a positive charge with a negative charge, get some currents flowing, get an ionization, and it glows, different colors. And what he was asking, well, how is it that when you put one of these things glowing in a dark room, you have the activation of a luminescent property? And he found something very bizarre. Because at one point, he had just a basic rock that it was basically concealed in a little thick box where no light was hitting it whatsoever. Totally black. It was in the same room as the cathode ray, which was glowing. But nothing that ray, none of its light was hitting it, and yet, nonetheless, it started to glow. Right? And so the question then became, well, what's the nature of this process which seems to be penetrating the box that this thing is located in, that is hitting it, causing it to glow?
The relationship that's not understood.
Yeah, because ultraviolet light didn't do that. So there must be something else within that too, when turned into an ionized gas emitting light, was then penetrating that thick substance and causing that same process, that same effect.
Any thoughts on why this or how this might relate to collapsing and therefore using sound and water and how that generates noise?
That's probably, I mean, this is the thing that we're probably dealing with some fusion process. I'd like to say, yeah, there's definitely, that's a whole other
Beyond that, you had a subsequent discovery later on, which I can maybe go through later, that on top of all of this, you have another type of radiation, which was of an even finer wavelength on the scale of atoms, called gamma rays. On the other side, you have microwaves and radio waves. Yeah, this for now, that's good. So by the turn of the century, you had complete revolution. And it's not a coincidence that that spike you see in population growth around the world was the effect of certain applied discoveries that had occurred in this very dense period of creative thought, where people like Madame Curie, Einstein, Max Planck were just making discovery after revolutionary discovery. And what's most important is finding ways of applying those discoveries to save lives of humans and make life better for people. For example, if you go 2 slides ahead. 3. Another slide. Another slide. Another slide. Another slide. Okay. This is the first X-ray that was immediately done by Roman's wife. This is for diamond ring. Within months, this was being applied to set a young child's broken leg back in place. Within a couple of years, saving soldiers launched into war. Tens of thousands of soldiers were saved through this almost immediately. Go back to the cosmic rays. Okay. Back. Okay. Now, why is it silly to be afraid of radiation? Well, not only is this electromagnetic spectrum everywhere, but what you've got, this is the Crab Nebula. Can you guys all see that this is obviously the same thing? Really? Can't, obviously. So they look totally different. These are different filters, right, of one single nebula. This is what you see in a telescope with no filter. But when you look at the X-rays that are emitted from it, you all of a sudden have a completely different structure with a highly active center and a spiral-like pattern that's emitting a huge amount of X-rays out from the top and bottom. Infrared has a completely different quality. Radio waves have another quality to them. This thing exists within our Milky Way galaxy. Chinese astronomers witnessed this thing being born in 1077 AD. It's literally, this is within the human experience that we've been witnessing something grow. And so far people have theories of what this is, but there's nothing really clearly defined what exactly we're watching. Some people say it was the death of the star. Other people say it's the birth of the star, and that's most likely, probably. But the point is, we've got processes occurring here that disobey all of the laws of standard quantum dynamics. You've got gamma rays that this thing started emitting in bursts of millions of times more than anything we were able to imagine could have ever existed, and cool down within seconds last year, 2 years ago. If we're more locked into our, you know, if you're in an imperial society, you're going to be more locked into your mathematical standards that are accepted by the priesthood, rather than letting them go if they're holding you back from making discoveries. So you do actually have people finding some very good hypotheses, but there's this big problem of the British Empire, which has had a long history of holding back science and sabotaging it, which is still at work today. Now, what you see coming out of Russia, China, India, in going for this aggressive fusion, space-based economy is very, very bold. Now, this is just one item within our Milky Way. People often have this idea that we live on a planet with a sun, and between there's a lot of like darkness. So people watch things like Gravity. Right? Does Gravity make you want to become an astronaut?
The movie.
With George Clooney? Yeah. No. You guys ever seen Gravity?
No, it's basically lost.
Scary. Very scary. Yeah, you're basically dying in space. Like it's a cold, dark place that you don't want to be in. Otherwise, you're going to see a lot of aliens. But generally, there's very few movies that actually invoke an optimistic idea in young people who watch them that space is actually our home and someplace that we can discover and be a part of. Not there. But if you look at it, it's not an empty thing. In fact, when you take on these different, if you look at the entire electromagnetic spectrum and all the cosmic radiation, which is everywhere, even moving through every square volume of this very room at all times, you're in a hyper-saturated, dense domain of radiation. There's some of its particles. Some are alpha particles, positively charged, beta, negatively charged electrons. You've got cosmic radiation of all sorts. It's everywhere. And go to the next slide. This is an artist rendition, but I think it's a point across. Like even what seems like just an Earth going around the sun is not the case. You've got hypercharged Van Allen belts with antimatter that we don't even know how the hell it gets there, but it's there. You have a environment that the sun relates to us, where we are constantly, our ionosphere is constantly filtering out radiation from the sun. Our ozone layer is constantly filtering out more violent forms of energy being emitted from other stars as well, which all are filtered into, our own biosphere, which play a very big driving role in evolution, the very existence of species, of life on Earth, which has mediated the development of the ionosphere, the atmosphere, the ozone layer. They don't just exist in abiotic space. It requires living things to be there for these processes to have come into being. Right? And there's another problem. People often say, "Oh, how did life come into being on the Earth?" Isn't it so amazing that the environment was just so right that life just happened? Well, no, if you go back 500 million years, the evidence has that the environment wasn't very hospitable for life. Right? You didn't have some comfortable ozone layer. The ozone layer itself, which cuts out a lot of the harmful ultraviolet radiation that would kill you, was an effect of free oxygen being emitted by photosynthesizing plants. Were it not for the development of that process, no ozone layer. So this whole process is a dynamic field of change, of flux. But there's a constancy to it nonetheless. But you'll never see it if you believe in your senses, or any law which is based on your senses. And that's really the lesson that we have to look at when we think top-down about the universe. And that's why it's stupid to be afraid of radiation. But that's just one type. Because if you look at the other type of radiation, if you go back to the next slide, Mark, there's not just radiation coming in around us. In fact, these are just several leading radioactive isotopes that are present in every human being. You guys have ever had a banana? You guys like bananas?
Love them.
Okay, you love radiation. Because there's more potassium-40 with beta decays. In fact, 4,000 beta decays occurring every second when you eat a banana. Carbon-14 is very radioactive. 3,000 beta decays. A lot of gamma rays are being emitted with every beta decay on a very low level. But the fact that it's low level as well, without this, they actually did studies on laboratory animals where they took out these specific isotopes just to see how these animals would do with their regular food. And what do you think happens to these poor little hamsters and rabbits without radiation? They die.
To be worse.
I was hoping it would just end the sadness.
But it was reversed. When they put it back in, to make a bad story happen.
You're lying to me now.
No, it's good.
Can I have some water, Paul? Thank you.
So sorry again.
They took all,
The radiation out of the banana?
Out of the food. Out of the animal and hamster food, yeah. So just removed the isotopes, only left the non-radioactive isotopes in there. So it still is chemically identical. But there's that lack of something special. And that's the thing. One of the beliefs that have been predominant, especially since the whole paradigm shift in 1968, where, not coincidentally, we also got rid of our industrial economy and became a consumer society with this post-Bretton Woods system, right, this totally disintegrated system. At that same moment of the cultural and also economic paradigm shift, which is completely orchestrated. This is not something that just happened. This is something that was thought through very, very deeply by those oligarchs which believe that they are gods and despise everything America has stood for since the time of the revolution. At that paradigm shift, what you had was the introduction of this belief that was linear no threshold hypothesis. This is the idea that all radiation, no matter what the dose is going to kill you, right? And it's based on the idea that, well, if let's say you have a large dose of radiation from a victim in Hiroshima, if that large dose kills 1 in 10 people, a dose 1,000 times smaller than the one that they got will naturally kill 1 in 1,000 people. Naturally. Which is basically the same thing as saying, if guaranteed drinking 200 bottles of this water will kill almost anybody who tries to do that. Thus, drinking 200 of these bottles, like what I'm doing right now, will kill 1 in 2,000 people. It's that lame, but that is predominant in the scientific community. It's predominant in the environmental community heavily, and at the anti-nuclear movement that's been active for many years. That's at the heart of their arguments to denuclearize Germany, Spain, Argentina, us. Yep.
And this research that the movement has done that you're presenting is based on an interview that I think it was Jason Ross did with, I'm not sure. I read the article like a year ago, and I can't remember. But
yeah, it's on our 21st Century website.
Right. And so, did you mention this already?
I can send out links.
Yeah, because just as context, like it's like just so people know this, like the source of what we know about radiation is actually like this no threshold versus linear threshold or non-linear threshold is based on an interview with a scientist that was largely sidelined and blacklisted, I suppose, in the scientific community.
Well, he wasn't the originator of it. He was a large, well-spoken, good scientist who blew the whistle. But there have been many scientists over generations who, since the 50s, who demonstrated that low-dose radiation actually extends life.
Right.
And there's many case studies to go into.
Right. Okay.
But yeah, we can. And if anybody wants, by the way, specific links to follow up on after this class, then Paul will send them.
Or myself.
One thing is here, what we need to do is better understand what are the terms that we're dealing with and where does it originate from. If we go the apex of, I think, the genius that came out of the breakthroughs into the nuclear domain came about. Next. That was what I want to show you. Okay, let's go. Okay, here it is. Okay, so Henri Becquerel, Madame Curie, Pierre Curie, her husband. Without them, we can almost with certainty say that everything we have now know about the atom would probably not have been discovered. The idea that you can have a massive amount of radiation, I should go back to their ally, their close collaborator, go back now. Okay, Henri Becquerel made a very important discovery. When he was trying to figure out what is causing these X-rays that we can identify, he was thinking, well, maybe it's, again, some property coming out of these luminescent minerals. Right? That way just like these glow-in-the-dark toys you have when you were a kid, right? You get them touching light and then you put them in the dark room, they'll still glow. They're on for a while, right? It dies out. So what he would do is he would say, well, let's put different types of minerals in the sunlight, let them absorb the sunlight, bring them to a dark room, and then test the temperature radiation comes out. Maybe X-rays come from that. But it was really cloudy, unfortunately for him. So he couldn't carry out his tests. But his method, what he did is he said, well, using some minerals that contain uranium, he said, well, let's just try something there. He basically wrapped it, as he was going to do for all of them, in a black paper, put it on a photographic plate to see if it developed. Because if there was light being emitted, right, then it would be able to develop a photographic plate. And just put a little coin on it just to see if the coin would show up on the plate. And he left it in his drawer, waiting for actually in this case, he was waiting for a sunny day, and he just decided after it was just cloudy for like a whole week, he was like, well, let's just develop a plate and see what happens. And sure enough, even though this rock hadn't touched any sunlight, he developed a photographic plate, he had a little coin. So then, this was a core revolution. Because now this means that the whole idea of the conservation of energy, which everyone believed to be what governed the universe, was not true. Right? But there is just this quantity of energy that just moves, right? Nothing is created, nothing is lost, nothing is transformed. That was really shaken. And all of a sudden, there was a substance being emitted from within the mineral itself that was of a huge quantity of radiation, such that even within a small period of time, it was able to develop a photographic plate. this changed the way that we saw all of nature. What Madame Curie and Pierre Curie then did is they went and, I'm sorry if this gets a little technical, I'm going to try not to, but what they went and did is they basically said, well, let's go see if we can figure out if these blind spots on Mendeleev's periodic table go up to. Down two. When Mendeleev discovered the periodic table, there was like 12 blind spots. And she wanted to know, well, maybe he was right. Even though he didn't know about all these blind spots, he said that there would be something discovered there because Mendeleev was actually using a principle of harmony in his discovery of the composition of matter. So what she simply did with Pierre Curie is they took different forms of minerals and they tested it. They tested them to see if using an electroscope, which is basically two gold beads that have a similar charge that repel each other, they used this tool that Pierre Curie developed to see, well, do these seemingly inert minerals actually emit radiation? And if so, are they perhaps new things that have yet to be discovered? And so the way that worked was they basically the gas and air between these two charged beads, which have a common charge that repel, is neutral. If you're emitting like a beta ray, if there's beta rays being emitted, like electrons, it's charging the inner gas to be the opposite, so that it would then collapse. Yeah. And similarly, if it's ionized in the opposite direction, it would do the same. And the degree to which the collapse happens define the intensity of radiation coming out of whatever mineral you were looking at. So the revolution there was the discovery of radium, polonium, named after basically Poland, which then wasn't even a nation, but had a strong patriotic humanist movement that Madame Curie was a part of. And she knew that you're not going to have a real nation, which she really desired, unless you have a scientific identity. So she named this thing polonium for that reason. And radium, all of these things, they completely blew our idea of a fixed law of nature out of the water and moved us then towards a mindset where, yes, there's flux and change, as Madame Curie says in the slide before this one, where she writes, if we assume that radium contains a supply of energy which it gives out little by little, we are led to believe that this body does not remain unchanged as it appears to, but that it undergoes an extremely slow change. Several reasons speak in favor of this view. First, the emission of heat, which makes it seem probably that a chemical reaction is taking place in the radium. But this is no ordinary chemical reaction affecting the combination of atoms in the molecule. No chemical reaction can explain the emission of heat due to radium. Furthermore, radioactivity is a property of the atom of radium. If then it is due to a transformation, this transformation must take place in the atom itself. Consequently, from this point of view, the atom of radium would be in a process of evolution, and we should be forced to abandon the theory of the invariability of atoms, which is the foundation of modern chemistry, in 1904. So in what way is it changing? So all of this whole periodic table, go back to the periodic table, this whole thing is no longer just, it's no longer just there. There's now an idea of becoming, which Plato has in a very important core of his philosophy is both being and becoming coexist in the universe, which governs which. Is being a process of change being governed by a process of no change? Or is the process of no change governing change? What this points out is that, yes, you actually have constant change, but it's moving, like every atom, while it's giving off energy, it's giving off radiation, it's becoming something else, and this is called the half-life. You guys have heard about the half-life of different radioactive isotopes? So this is it. Everything above red, that goes all the way to what naturally occurs in nature, which is uranium at number 92. Everything is, that's uranium. So everything of 92 and below, which occurs naturally in nature that we find it, is constantly emitting different types of energies, of either alpha waves, gamma waves, beta, and in so doing transforming itself, not to become immediately lead, but rather to become a variety of things on its way to becoming lead. I'll go to the next one. And in the course of the next 6 or 7 years, what was discovered is that there's only 4 paths of all possible radioactive decay chains. Because why not go from uranium-238 to some other thing? Why not a different set of relations before you arrive at lead? with an isotopic base of 206. An isotope, by the way, I didn't explain that. You guys know what an isotope is?
Go again, try it out.
Okay. The atomic number of an element is based upon its electrons, right? The quantity of electrons around it. The isotopes are the neutrons and protons within the nucleus. So if you add them all up, usually you'll have the same amount of protons as there are electrons, positive, negative, which would balance out like an atom. But at a certain point, you start getting a lot more neutrons than you do the protons as you go to heavier and heavier elements. Now, when you shoot off an electron, it becomes positive charge. There's more positive energy now in an atom. If you get rid of a couple of electrons, now because there's more positive protons in the nucleus than there are electrons, it's got a positive charge. Then that's what you have as an ion, a positive or negative charge atom. In this process, what you've got are a motion where you're always emitting an alpha, as it emits an alpha, and it takes about this much time, 4.5 times 10 to the 8, I think, meters. During that time, half of that has become this, going to the 4, which then starts emitting beta waves. It takes 24.5 days for half of it to become protactinium, it is. And on and on and on. And there's only 4 paths. So that's interesting right there. What's causing that? So you think, well, if this is so brilliant, and it is everybody, in the scientific community embracing these new discoveries?
For this specific changes for
Yeah.
for directions or generally?
Beginning with the uranium-238, it'll take 4 different paths to get to light. I mean, 4 different chains. Yeah.
4 different chips.
Yeah, 4 different.
So there's 4 directions that it can go from one to the other. For something like uranium-233 or
That's usually a secondary feature. That's usually a step on the rung. It's a rung on the ladder, but it's usually not the beginning or last rung.
Yeah, so before we get to thorium-234, did you go 4.5 times 10 to the whatever divided by 2 to become half-life?
Before that? Yeah, exactly. This is the amount of years, so a very long time.
Yeah, but that amount of life divided by 2.
no, that is actually
Yeah, that's not exactly what it's doing.
Oh, okay.
Yeah.
So you never get to that.
You will, just you won't see it in your lifetime.
No, but look, I mean, 10 to the whatever. I mean,
10 to the 8.
Like,
Yeah, your great-great-grandchildren.
and that's a theory.
2 million years down the way.
That's a theory, which means
No, it's pretty concisely proven. I didn't go through the explicit studies that they went through, like Matthew and Peter and Ray Thompson as well. There was a group of scientists that were all setting up crucial experiments and things like that. I personally haven't gone through all of them, so right now I can't speak with full authority when I say this, but it seems pretty tight. And there might be more. Frankly, maybe we'll find something more. But this is probably going to become enriched the more we develop more and more isotopes. Because if you think about that periodic table, not only were there, let's go back to the periodic table. Not only, remember what I said, only 92 of these things exist in nature. Everything above 92 are transuranic, meaning they were made by people. Were it not for the intervention of the human mind into discovering the laws of nature and developing particle accelerators and what have you, then these other heavier elements would not exist. Maybe they would exist in another galaxy or another planet or a solar system that we haven't been yet. And the fact is that what this is pointing to is that there's a process of evolution which the human mind is making faster. We don't have to wait, for example, we could wait 1,000 years for a desert to turn green by itself. But if we're moral and we're not obeying an empire of gold, you can accelerate that to being like 10 years. What Roosevelt did for the Imperial Valley in California. We can do the same thing for the Sahara Desert. So you take what nature naturally does and make it more condensed. You're in a sense bending space-time when you're using your mind in this type of fluid form. And using this type of direction. On top of this, you've got about 2,000 more isotopes. So this is all the stuff that we only use like several hundred isotopes, but there's about 2,000 that we've created. And they all have different properties. So like this, like potassium, you've got like 8 different forms of potassium with different neutrons within it, each with a different property. And there's all sorts of anomalies there. Was that different isotopes? Yeah, exactly. And there's paradoxes that are yet to be investigated properly. Like one paradox is, why is it that the odd elements have so few isotopes while alkenes have so many? Like carbon has something like 14 or 15 different isotopes, maybe more. That's 6. But then other ones, the odd ones, have so few. So you have specific paradoxes that are presented, but we got more creative than we're doing right now in the scientific community. Yep.
Yeah, sure. Well, I mean, this is
What you're getting with the transmutation when you're going back down.
this is what they're
depleted uranium.
I've heard
Yeah,
about
like
that,
when you,
and
like waste, you mean?
somebody was telling me that
Like nuclear waste, right?
depleted uranium and Iraq.
A weapon. That was a weapon.
Yeah, that was biological. That was a weapon. So the idea, for example, of nuclear waste, which I guess the deeper question of uranium, right, as radioactive waste.
What you're getting at here, what transmutation points out to, is that we are capable of artificially. If you have like uranium which has a very long half-life, you don't really want to wait for 30,000 years of this stuff being radioactive underground, which is what we do today, right? What we do today is we take our waste, for 20% of the radioactive fuel, and it's called waste, and we bury it. Right? We do that because Jimmy Carter decided in the 60s to abandon the process of, on the one hand, reprocessing spent fuel, because he had this whole, idea of non-proliferation, all spent fuel, when you spend the fuel, you create
A lot of enriched plutonium, and that could be used for a bomb. So they said, instead of doing that, we're just going to bury
this radioactive substance. And there's other policies too that were canceled, like investigations into how do you use high-density lasers to transmute very radioactive isotopes into something which is very short-lived, like with maybe a 24-day period. So instead of waiting super long for an isotope to run its vacation, you just like condense it and bring it to life really quickly.
These are things that we were closer to doing 35 years ago than we are today because of the shift towards
A depopulation, post-industrial
policy that came about in the 70s and was carried into the 80s, 90s, and now today is saying, we need to collapse our world population to 1 billion if we want to be sustainable. So all of this, there's this very malevolent intention which has been
sabotaging all of these breakthroughs. And most importantly, too, if you get, and I guess this is a part of the point, if you actually get to the point where we utilize, as China and Russia are intending, a full fusion process and using
plasmas in order, because what you find is that in plasma,
when you take an ionized gas into a really hot temperature, like 1 million degrees or more, which you have with the French tokamak, that's a plasma, it's force-treated matter. In that environment, you have a high potential for fusion reactions, where all of these later elements, like tritium and deuterium, begin to fuse and become helium, giving off a lot of energy, more than you even get with fission nucleus. This is fission. So it's heavy elements breaking up. Now, with the opposite, fusion, which is really where we want to be, and up until now, it's only been used in seriously in the form of bombs. But what we really want to do in controlling this process, with helium free from the moon and beyond,
is to literally
you could basically bring everything into a plasma state. All of your nuclear waste that we've got sitting there right now, not being reprocessed and not being transmuted, it's just sitting there. You could take that, bring it into a plasma state, and then separate out, as Paul was going through regarding how you one form of mining, that we have to redefine it for mining if we mine the moon. You can't just mine the moon as you would Earth. There's no deposits. What you'd be able to do is then separate out all of the specific elements that you want in pure form, whether it's just whatever you want. Like there's think about like a cubic
meter of seawater has within it, in a very diffused form, more iron than like the United States produces in a year. So you just
cubic meter.
Cubic mile, sorry, yeah, a cubic mile. So you could just feasibly take that into a plasma, pull out whatever pure like iron you want, and do the same thing for radioactive material as well.
I was mentioning you know how gold is formed, right? No. Gold is actually formed in the stars, and if you use gold for very, very, very small amounts. And the biggest problem with production of gold is that the amount of energy it requires is about the amount of energy that, say, like two stars need each other, which is what produces that. Another thinking of this, if you go to nuclear fusion and further development, like a few decades of development, and making that even more efficient on a larger scale, they basically think they can actually, in the process of creating rare metals that we don't think, right now we don't conceptualize.
Well, it's like gold will effectively become the new aluminum. That's like too heavy though. Huh?
That would be too heavy.
Well, you're about aluminum, though, right?
Pardon me?
Aluminum when in the 1760s?
All the way to the 1800s. Aluminum was really hard to make. It took so much energy to take this alum and then, turn it into something like a foil. Right. So Napoleon had his personal cutlery and dinner plates in aluminum. He's the side of it. Best. And nobody else of the nobility was even allowed to have aluminum cutlery or silverware or aluminum. And it was because it was so damn hard to make. And when you started having the advent of, things like hydroelectric power, things that came out of the later energy revolution, all of a sudden that abundance of energy made it really, really easy to make aluminum. So it became something you could practically sound. Even the Washington Army had its cap of aluminum, right?
Chocolate wrapped in aluminum would be like,
unfathomable.
Now that's all you got.
It's basically, gold lollipop with stick, right?
But you're talking about the radiation as if it is not a problem.
Well, I'm saying that you have to understand it. It can be made a problem.
No, but I'm asking you, the question is, what is the difference between the inoffensive radiation and those that coming out of a bomb?
Oh, well, the one that comes out of a bomb, you don't want to be anywhere near. It'll kill you.
Yeah,
I mean, obviously, like that's the point. Is that if
the
you
wavelength, what is it like?
Mostly just dosage. I mean, you don't want to like literally suck on a uranium stick or anything. But you want to be wise about this stuff.
You don't want to be in a society which is forcing all the nations to build up bombs like we did in the Cold War, which was, again, not something that happened. That was an artificial intervention made by the collapse of the British Empire after World War II, who wanted to destroy Roosevelt's policy of getting rid of imperialism and building up sovereign nations, which even Stalin was on board with, right? Stalin and Roosevelt, they got along much better than Roosevelt got on with Churchill or Churchill-Stalin. Neither Stalin nor Roosevelt trusted Churchill at all. They were in fact enemies. No, so ironically, who becomes allies and who becomes enemies when Roosevelt dies? Well, it's not a coincidence that Russia and America, who were formerly allies, became enemies, and Britain became the Anglo-American Empire, right? They took on the friendly role.
People have such a fear of radiation that they think that little bits of radiation are causing little cancer. Or they think that if you're a nuclear power plant, there's going to be cancer. It's really bad. It's really bad. It's not that way in France because they're the education. But it's almost like a middle age, medieval age hysteria. It's really bad. And this is so deep in the culture. It's very important that people take a look at it, examine it, understand what it is. Modern medicine depends on radiation. But I just want to say that this is really something that we're up against. Psychological hysteria about what it is. And if you know what it is, you know how it works, then you know how much, how much radiation is required to damage to somebody. But then most people are walking around thinking that most of the cancer that's going on in the world is caused by radioactive substances or things like that. And this is Holocaust, the worst case of this. And, like, she's, I mean, it's just absolute hysteria. And it's a problem. It's very deep. And with the Chinese going with control over the diffusion, I think the hysteria will ultimately take care of itself.
The Sputnik factor can take over there. Yeah.
I just want you to comment on this fear with the sun and skin cancer and other people never come through because people don't know the skin. And it seems like an extension of it.
I don't know enough about that to comment.
Well, I can say this, because I have some answer. I can tell you this, that if you look at a photograph of people back in the 30s or 20s, they all wear hats. I mean, they don't. People took the sun seriously back in, before the became, a big thing about becoming sun. You don't need sun for health. But if you look at the pictures of people,
Well, so one thing is definitely true is that they know that, like, there's a study done in California in the 70s when some Chinese, this is a bit of a secret, but some food from Asia had come into the United States, and there was a big pandemic, and what they found was that there's this one building, and they just been
Experimenting with these,
full spectrum windows, and
what they found, interestingly enough, because
most glass, most melted, any glass that comes from purely melted sand,
cuts out ultraviolet. You get really hot by
sand, but you're not getting ultraviolet light. That's an interesting property about just the middle of the sand. But they created like these windows all over this office building with full spectrum, letting the full sunlight, and not a single person working within that building got sick. Even their family members, everyone, the whole area of California had like a 1 and 2 hit ratio.
where people got sick.
And nobody in that building. So, you want certain low dose, a certain quantity of UV light, but at a higher dose, just like they never know radiation. That's bad for you, right?
So yeah.
Well, actually, here's how to find this. I don't know where this study was done, but it was seem to be realizing now that skin cancer actually is, the chances of developing skin cancer is exponentially multiplied if you use sunscreen. And a lot of I come from a country where we're basically drowning in sunlight. We can't help it, right? And how many cases of skin cancer do we have?
Yeah, I would say one thing that, before we go off into the segues, but one thing is that we have two very important events that are occurring in the next couple of weeks.
The first being a major.
And one of the reasons why I'm down here, and we're going to be joined by another member from lunch for y'all in a couple of is that there's a major 4-day conference called the Pacific Nuclear Basin Conference of all the different Pacific countries whose engineers, policymakers will be gathered for 4 days of seminars and what have you. Some of it's brainwashing around the future of nuclear power. Of course, the thought here is that we're bringing these experts from China and India who are much more serious than we are, and we're saying that we're the leaders, we're going to tell you what's how to deal with the nuclear energy sector. Even though, ironically, Canada and the U.S. were sponsoring it, the ones who were shutting it down the fastest.
So we got to get in there and present that paradox, find allies, get a lot of lit out, and bring people
within that environment into our conference, which everyone here I'm hoping will be able to come to. So it's going to be on Friday from 2 till
7 on the 29th of August, the day following this big
nuclear conference.
We'll be having it at the Vancouver Public Library. So, I mean, the idea right now is if you're interested in coming, let us know. Robbie or Paul will put your name on the guest list.
Robbie will put your name on the guest list.
And we do need as many people as possible to come and just even to help out and to, we're familiar with these ideas and things that just started coming that are not as familiar. You are somewhat familiar, and the people that we're inviting may not have ever heard of them.
Yeah.
Fill seats.
Yeah. And one thing also that I would say,
the intelligence that Paul is providing every couple of weeks, and what I'm working through here in science, geopolitics, history, largely this is the effect of our being a part of the best intelligence service in the world. The EIR has been around for 40 years as of this year, it's the 40th anniversary. Never missed a single week.
And we get this to students, all the embassies, different MPs, people all over Russia and China have access to these things. And it's being in place also in the United States, where even state and federal deputies are also receiving it. So we want the population to know exactly what the leadership in Russia and China are reading about and what LaRouche is saying. So you guys can pick these up individually or get a subscription. I mean, we usually, it's $30 a month. We usually encourage people to do a few months at a time, do a full year if you can. It helps us enormously with our interventions. It's definitely worth the read, and I just say if you guys can, make the investment and share it with your friends. Just throw that appeal out there.
And if you do want to come, we can send you the actual invite. We don't have as many right now, but we can send you the information. And I believe we're getting a Facebook page.
For the event.
Actually, since you don't have email, I'll give you one of these invites.
All right, any questions? I guess we can just open it up.
Yeah, I don't know if you mentioned it or maybe I missed it, but what's the role of radiation with my understanding is what I think the external science is that it's going to play its role in just the creation of sporting seeds and life coming from radiation. Without the radiation in the sun, we wouldn't actually have that to grow life supporting on Earth. So I think that's a good point to make that radiation actually helps the propagation of life, opposed to this ideology of radiation killing.
Yeah.
Yeah, no, that's, I mean, yeah, see, these are all, this is a whole field of study which has been really cut off since since Louis Pasteur and since Bernatsky, Vladimir Bernatsky, since these were the best minds of their nations and of the world since they died. This isn't really honestly taken out seriously. And what we do know, like the relationship of light and life, like the New Age movement is kind of taking this over right now.
Yeah.
Well, really, like the honest relationship between the principle of light and the principle of light, and that means the entire electromagnetic spectrum, have a specific relationship that we cannot account for basic functions in nature, like evolution, if you don't take into consideration the context. You want to take that context and react it when evolution occurs.
What the principle of life does is it takes the radiation coming from the sun, from outside the sun, and the radiation coming from the earth, and the decayed elements, and turns it and uses that energy to create biological matter, which then uses more radiation to create more biological matter, and so forth. So the whole process is driven by radiation. And the idea that somehow space is empty is not the case, because the thing is nothing is space is radiation. And it's radiation that connects the Earth and the solar system and the galaxy to the Earth. It's actually radiation. It's actually, and there's living processes that develop off the radiation from the Earth, from inside the Earth. There's processes that develop from radiation from the sun. And there's all kinds of changes that occur depending upon when the Earth's solar system is in the galaxy at certain points. It gets much more cosmic radiation. Other times it gets much less cosmic radiation because it's shielded, and so forth. These are interacting and with the Earth, that they're interacting with. And what we also discover is that we just discovered this recently, that radiation from cosmic radiation is the primary element in creating clouds. So, there is this interrelationship between the Earth, the Sun, the solar system, and beyond that is connected by radiation, and it's the driver of what living processes use to transform it. Here's what's happening. We are about to become the
actual drivers ourselves of that process. By reaching the fusion age, we essentially go into a world where we create the forms of radiation that we want and the forms of energy that we want to further drive that process. So this is big. This is a big development. It's like the pre-fire for the human evolution, human society evolving pre-fire, post-fire. It's that level of power. Human beings before they harness fire, it was very different after they harness fire.
Yeah, I have a really funny, weird anecdote. There was a chemist that I was speaking to from India just the other day at Canyon, and he began by telling me, "Oh, nuclear war is impossible to stop." I gotta deal with this. Went into it, and what he agreed on was that nuclear fusion is inevitable, and that China and Russia and India are moving in the right direction, and it's inevitable. We're going to make it. But nuclear war is inevitable. And then at the same time, it's like, but even if we stop nuclear war, we're still overpopulated anyway. So all these contradictory theories, because it's like, obviously he's thinking that you could imagine the same type of world that we live in, the whole consumer society, except now with fusion power, and everything else is the same.
It's interesting. His glasses happen.
Yeah, you're right.
We got like their fusion, but let's not tell you everything's just
Well, if I could just make just a comment or observation, and I could be stating the obvious, but really to combat the propaganda is what I got from reading that specific article that I was mentioning earlier, is that our understanding of radiation is that you either have it or you don't, right? And that we have zero tolerance for it. Mm-hmm. But what we're discovering, and what Matt and Paul are talking about, is that it's 2 degrees, and we can control the degree of radiation and how we develop it. We can control it, but we have these ideas of mad scientists in our heads who, science is scary because of mad scientists, but if we had more scientists who were moral, it's like, why can't we have moral scientists instead of mad scientists?
Well, it becomes something you're not even allowed to have an opinion on. The way science is treated today, it's like, unless you've studied 7 years and gotten PhDs and you've crunched all the numbers, and unless you've gone through that process, you're not allowed to have any relevant opinion about scientific matters. You have, popular science for stupid people, but we don't have to respect it.
Right.
So to make sure they filter out anybody who
Well, yeah. And to tell someone with a degree that they've been heavily indoctrinated is a hard.
It's a problem.
So you really need to come to the conference.
Then the no threshold theory is actually a prime example of scientific conspiracy that you can point to any reading and repudiate the nature of conspiracy. The guy who got the Nobel Peace, the story of the article tells about how the guy who won the Nobel Peace Prize for radiation was for the linear model, got the Peace Prize, knowing full well that that was full of bunk.
Right, and he admitted it later on.
Yes.
And this is the fear that that everybody lives with Fukushima and all this stuff, is that you can't have any radiation.
Well, the media's controlling. I mean, when people don't believe me, the important thing is when you lose this naive faith that the media might not be lying to you, you're somewhat free. Like the idea that obviously Putin shot down that airplane over Ukraine. Obviously, the Syrian government used chemical weapons on its population. Obviously, these things happen. All of the media says so. Must be true. So the paradox is a lot of people who have a critical thought towards the right-wing agenda in the media about pushing war often get really lazy when it comes to the left-wing facts. But obviously the media is telling the truth about Fukushima. Yeah. Obviously it's telling me the truth about all these other things.
Right.
Yeah.
Yeah, but the radiation on the Fukushima cannot be good.
Right? A lot of it's blown way out of proportion. I'm not saying it's a good thing, but a lot of it is
Not
way
one
out of
person
proportion.
has actually died from radiation from the damage to the nuclear plant. All of the deaths in that area were caused by the earthquake. There's not one.
Gas explosion.
Because really the history of human society has been a battle of ideas, right? We know that human society, and I think Paul went through this wonderfully, human society, though we have many differences as humans, we live in a material world, we live in space, and we have a duration, right? We're born, we die, and every one of us has differences physically from the other. Every culture has differences from the other, different cultural experiences, reflexes. But regardless of all of this difference, we do coexist on Earth, and we do have certain qualities that we share in common. Now, the thing that pisses off imperialists is the fact that there has been, like Paul was going through, a quality within that's manifested itself in various cultures over the millennia of individuals stepping outside of the limited matrices of their time. Right? People who have chosen not to be bound by their cultural traditions, who have chosen not to follow irrational habits that have been expected upon them by their forebears, and have chosen instead to be creative and make discoveries of qualities that govern the universe. Right? When we talk about unifying the world amongst all these different various countries come together, we don't mean we want them all to have a unification of technologies. Three-party garages. We're not talking about these things. What we're saying, though, is that what we have with China and with Russia, both with a common orientation towards developing industrial and automated processes to mine helium-3 and other rare earths on the moon, is an expression of this human quality society. Geniuses. We're going to or at least create an environment where genius can flourish, like pretty culture of engineering scientists, by having visions for the future. To do the impossible. And people like John F. Kennedy did that. Right? Many people here are much older than me, and I think that we have some memory of what went on when John F. Kennedy and people who worked with him, like Martin Luther King, Robert F. Kennedy, were inspiring people to think not about your limits, not about yourself as a consumer, but rather think about yourself as a creator first. Of course, we all consume, we have to, or else we start walking die. But is that where you're going to locate your identity? Right? As the consuming species? Or is your primary motive and the species character of primary creative, productive species? Right? And when you look at the divergence right now between where you have an advance towards adopting a nuclear strategy with both advanced second, third generation moving towards fusion economies, you have primarily the BRICS that have 65%, and all of the other countries, only 35% that are not BRICS. In fact, what we have is coming out of Germany is the contraction and destruction of the nuclear potential that was built up. So Germany is now planning by 2020 to have a 0% nuclear basket. Spain is going down now to a similar level soon, if the current system's attention is maintained. And against this, you have those, especially coming out of India and China, who are saying no. And this came out of Copenhagen, right? If you guys remember, in 2009, the break fully became defined when all of these countries, especially in Asia, were expected to come together and sign a suicide pact. Basically say that we will sign binding treaties to get rid of our sovereignty, have human beings have that same obstacle. And from the 1780s, what you're looking at here is the U.S., but it's very similar in Canada. What you guys, 5 kilowatt per capita was what the whole system offered to every individual. Like every individual who has maybe, I think it's 2,000 kilowatts of energy within every human being. No, sorry, 200, sorry. Every human being, if you look at the general work that we emit as a biomass, as a species that exists, it's like, we didn't even have fire, it would be about 200 kilowatts per individual of work that is generally done on average. By the time 1780, the American Revolution rolled around, that had increased. It says, it was actually 2,000 kilowatts, based on the steam power that had just been used to certain other
forms of fire and a little bit of coal. And that didn't really change that dramatically until coal became more used and adopted, and we had an increase of the per capita power that every individual had available to them in their consumption and production capabilities. That, again, you have a limit. There's only so much coal you're going to give. At a certain point, that's going to collapse. So, at that period, you had a move towards natural gases and oil, which it served its purpose. It was useful when it was.
It still is kind of useful, but frankly, rather than continuing on with the policy that
John F. Kennedy, that C.B. Howe in Canada, and many others around the world that Charles de Gaulle were moving towards, which was a nuclear-based economy to get rid of,
to overcome
new global green arrangements to enforce programs of
cap and trade, carbon cutting emissions, things that will, as an effect, force these countries into massive depopulation and chaos. Because when you have over 1 billion people
in your society, windmills and biomass is not going to cut it to sustain that population. And what China and India especially did is they basically locked themselves in the room and said, we're not going to sign a suicide pact, thank you. And they made a complete break in energy and geopolitical policy.
What the empire hates when you have people unifying around a policy like this is that, well, geopoliticians, they thrive
on differences, right? On keeping everybody in a world of scarcity, looking at the other as some foreign thing that you can't really relate to, right? So they cultivate a better atmosphere for better uranium and also civil war and conflict that we see coming out of Palestine and every other conflict in the world. This is geopolitical art, an evil art, if you want to call it that goes back to before Babylon. So this is just an old precedent. Now what we have are these countries are going with a program that we left off, and go to the next slide, that we actually had as a governing principle up until the late 60s, early 70s, when you can see, this is the paradox right there. At every state where a society chooses to exist at, your resource basket is finite, naturally, right? Of course. And every moment that goes on, if you do not make creative discoveries to go beyond what currently exists, you're accelerating a collapse point, just like any other animal species that is in its environment, it collapses. Because that animal species, that rabbit population, isn't going to find a better form of agriculture to produce better plants.
So that we can actually make leaps outside of what is already known
and discover those laws that the universe has shaped. Well, let's shape the universe and that shape us in our development, and then act upon those discoveries in ways that have the effect of making our society a better place for our children and grandchildren, everyone from after. And when we don't do that, and when empires crush that Promethean spark that says, no, fuck is use, right? Fire exists for everybody. It's not the possession of a mighty few who have the will to power. That Promethean spark, when that's crushed, you get a dark age.
And there's a science to dark ages just as much as there's a science to
Renaissance. And so what Paul went through, and what's very important for everyone to conceptualize here, is that we are seeing the emergence of a completely new system, which coming out of the Brits and their affiliations.
Many cynics who just aren't
that well informed about history and what have you will otherwise say, oh, that's just another empire taking control, vying for control of the system. Right? We have this empire that's collapsing, yeah, sure, but now you have this new red dragon and this new alliance that are just there to take over the system now. And in fact, what they're missing is that it's not a battle of empires, it's a battle of conceptions.
Whether you unify your system
around this legalist system where everybody just gets into a fixed harmony, where everybody just
knows their role
and behaves according to a master class. That's one way to do it. Every fashion does it that way. Everyone knows your role, and don't like ways. And that system is an empire system, and that's one way to create a unification of the many. The other way is to actually say, no, we're going to unleash creative
optimism. We're going to make our